the plan here today is to do talk about the test stuff. So if you guys had a chance to look at the my test description out here in the content library, is there any questions about like what any of these skills or things mean, or what I'm trying to say? Violet? Sure. So for a squeeze theorem, what I need is if I have two functions, f and h, that create a lower bound and upper bound for g, and the limits of the lower bound and upper bound are equal at a, then the limit for the middle function is also whatever that value is. Okay. So let me think here for a quick second. Like, let's say we have x squared or negative x squared less than x squared cosine x less than or equal to positive x squared. So we've given you this. And I want to find the limit as x squared times cosine. So what I can do is and I want, as it approaches 0, I guess I need to pick a value. So to do that, I can check this limit, and I can check the other end limit. And since they're the same, I can say by the squeeze theorem, limit as x approaches 0 of x squared cosine x also equals 0.
So they would give you that top portion?
Yeah, you'd be given something like that for sure. Michael?
Is it just like a question for like the test? Like, so for the multiple choice questions, how are you like grading those? Like, is it based off like our work or just
the answer?
Just the answer.
But keep in mind that like I think that the multiple choice is in the no calculator section, right? So probably have to do something. I mean, if it's one of these table, evaluate the limit using a table, like you probably just are looking at it, writing down the number kind of thing.
Like partial product.
On the multiple choice, nope. Paulo.
For the test multiple choice questions.
Yeah.
Is there an answer key?
Yeah, so if you look under, I have test 1 practice number 1. Oh, I'm sorry. Test 1 multiple choice. Oh, I don't have did I not put it in here? I swear I did. Well, let's put it in. Yeah, I have them. My apologies. I thought that was in there.
Those multiple choice would be a good way of studying just for practice.
I think that the multiple choice that I will have on there are going to be really similar to the multiple choice that you see here. So they all have an answer and like a little blurb about how I got to the answer. Yeah, absolutely. Do you guys want to look at any of the specific multiple choices? If we worked on some that were like, ooh, that's a stumper. They're all stumpers?
The other multiple is the test one practice.
Oh, sure.
I think it was an easier one, but it was number 3.
Okay. So this says the value, the graph of the function f is shown for the figure above. The value of the limit as x approaches 1 of sine of f of x is. So what I would want, or the key idea here, is that we can push that limit inside. So the limit there is going to be, for f of x is 2, right? I can read that from the graph. And I just type that into my calculator, making sure I'm in radian mode. And then I pick the right decimal. But that's the idea.
So it'd be part, you pick 2 just because.
Well, I'm doing the limit as x approaches 1 for f of x.
Oh.
This is the graph of f of x. So at 1, I trace up and over, it's 2, right? So it's whatever it is here. Okay, so it's sine of 2. So B answer A. Lena. 10. Okay, it says let G and H be functions defined by yada, yada, yada. If f satisfies G is less than or equal to f is less than or equal to h for all x, what is the limit as x approaches 1 of f of x? So when you see this, what do you think? Squeeze theorem, right? So what I need to know, or what I need to check, is I just need to do the limit as x approaches 1 for g of x. What kind of function is g of x? Polynomial. So it's continuous everywhere, so I can just do a direct substitution, right? And same thing for h, right? And what do you notice here? They're not the same, right? That's it. Does that feel okay, Michael?
Can you do it number 26?
On the other ones?
I think so.
Yeah. Sure. Oh, this one's a tricky one, huh? Okay, it says let f be the function defined above where k is a positive constant. For what value of k, if any, is f continuous? So I noticed that these pieces, well, the first piece is polynomial, so I know that's continuous over its domain. And this is a quadratic, so I know that's continuous over its domain. So I know that like my right-hand limit is equal to f of x. I just need to find k such that the limit as x approaches 3 from the left equals the limit as x approaches 3 from the right. So, let's write that. So I have this, right? If I plug, goodness gracious, Kulik. All right. So I can plug in 3 for x. So far, so good. And then I just need to solve this equation for k. So let's multiply both sides by k squared minus 3 to get it out of the denominator. So something like that. See this guy right here? You know what that means? This would be a calculator question on an AP exam. So how would I solve this equation if I have access to my calculator? So I would graph and look for the intersection, right? So I would just do like, I'm going to replace k with x's. But I'm just going to do like one of these where I type in everything on the left-hand side, and then one of those where I type in everything on the right-hand side. I don't have a good idea of like where this is going to be crossing the x-axis, but I'm just going to use this as a little bit of guide where I can just go from like 0 to 10, right? If there's an answer, should be on this list between 0 and 10 somewhere. That feels like good enough. And I only care about it crossing the x-axis, so I'll just go like -5 to 5 so I can just see the x-axis somewhere. It doesn't need to be big. I don't care what the shape of the graph looks like. And I say, okay, there's one answer right there. That doesn't feel like the spot it's supposed to be at. Second, 0. Yeah. Did I mess something up here? Let's look real quick.
Wouldn't you have to put the 16, like if you're looking for zeros, wouldn't you have to put 16?
Oh my gosh, yes. I'm so stupid. So we should be like above and below 16. Yeah, so let's just do like 11 and then 21. Yes, thank you, thank you, thank you, thank you. If I would have subtracted the 16 over, then I could have done what I did. But there's my intersection. Second intersect, 2.08. Does that feel okay?
Yeah.
Thank you for catching. It's like, why didn't that work? What did I do wrong? And it's because I didn't actually do what I planned on doing, was finding the intersection. I was looking for a 0. Right? Oops-a-daisy. I did, yeah. So that horizontal line is y equals 16. Right? So I'm looking for the intersection with this function, with that function, and that's my solution.
So you just did total to the left?
No. You could have also done this and then found the 0 where it crosses the x-axis, or you could leave it on the other side and find the intersection, or you could have just graphed these two things and found the intersection. But I didn't want to do that because I didn't know where the y was going to be, where they'd cross. It felt like it was going to be kind of a wild goose chase a little bit to find a good picture of that. That's why I like having a constant on one side, because it makes, okay, now I know where the y, what my y's need to be for my window.
Yeah.
Does that make sense? Okay. Finn.
You just like plug in the answers. Like,
Okay.
Yes. But what if this is a problem where appropriately you could do it without a calculator? Right? Like if the algebra was not so sucky as to where you had to solve like a 5th-degree polynomial, which is unreasonable to do without a calculator, but if it was just like a quadratic or something, you know? But yeah, you could certainly have tested it and done like a little guess and checker, for sure. Do you guys get what he means by guess and check? Okay. What else, guys?
Do 27 on the same thing.
Yeah, sure. So it says that the function f is continuous at 3, and we're told that f of 3 is equal to this based on the statements above, which has to be true. Okay. When we say f is continuous at 3, what can I say? means that f of 3 is equal to the limit as x approaches 3 from the left of f of x, and also equal to the limit as x approaches 3 from the right of f of x. That definition for continuity at a point, you will want to know. That's one of like the 3 things, like definition or theorem that like you gotta have. Definition of continuity at a point. If that's the case, then I can just sub f of 3 in for those 2 limits. And so if I like subtract them over to the other side, like those would cancel out, then I subtract that one over. So I have f of 3, negative f of 3 is 1. So clearly f of 3 is negative 1. And that's it. So the key there was using that, how to use that definition of continuity, how to use that continuity piece to just turn it into like, oh, this is just like an algebra 1 problem now. But like you needed that definition. So those 3 things like you gotta have that are kind of definitional or theorem. Definition, continuity at a point, squeeze theorem, intermediate value theorem. Okay, those are the 3 we must have. Those are things that you want to commit to memory. You'll use them frequently. They're things that the AP will expect you to have memorized and then you can use in context. They will never ask you to quote anything, but there'll be problems like this where you just can't do it if you don't know what, like literally know what continuity means. You know what I mean? Like if you just have like a vague understanding and you don't know the definitional of it, it's not much you can do with this problem. What else? I have a fun one for you. How do we do something like this? Can I do a direct substitution? No. Why not? 0 over 0. Great. It's one of those indeterminate forms. That tells me nothing. What can I do with this? Okay, here's the trick. So we have to clear this absolute value. Who remembers the piecewise definition for an absolute value? So if we just have the absolute value of x, when we do an absolute value and I plug a positive number in, what should come out? That same number, right? Well, let's just say non-negative. If I plug a negative number, what needs to come out?
Negative.
Well, the opposite of it, right? Everybody's okay with that idea? So if we do that same idea now for the absolute value of x minus 2, well, I get just whatever x minus 2 is, provided x is greater than or equal to what? 2, right? Anything 2 or bigger, I'm going to get a positive number out. So just leave it alone. And then what should I do if it's less than 2? What does it need to become? So you could either write it this way, or you could write it with the negative sign distributed through. Either is okay. Is everybody all right with that? I would choose to leave things this way. I think that makes life easier. All right, so if I do the limit from approaching 2 from the left, that's going to be the same as just the limit as us approaching 2 of everybody's okay there? But if I do the limit as x approaches 2 from the right, well, that's going to be pulling from that one, right? So what do we say? And our work is below, right? Where we show them the left-hand limit and the right-hand limit don't match. But busting out this oldie but a goodie that you probably haven't thought about since Algebra 1, which was a long time ago, was super helpful. So that's, if you run into an absolute value in a limit, that's usually the trick. At least if there's a indeterminate case. I mean, if you plug in and everything is fine, you get no zeros or whatever, like, whoopee! You know, just go about your business. How do we make it harder? What makes that harder? Yeah, how do I write my absolute value, my piecewise absolute value equation for the polynomial? Right? Like, I know I'm going to have 2 pieces, one where I don't do nothing and one where I do the negative of it. But like, how do I know which one is which? Great, so we need to know where the zeros are, right? What are the zeros for x squared plus 5x plus 6? -2 and -3. Can everybody see that right away? And does that polynomial open up or down? Up. So where is it negative? Between -3 and -2. And then where is it positive? Well, everywhere else. Everybody's okay there? And then you can proceed the same way we did before. Actually, this is easier because it's not an indeterminate form, is it? You guys see that? I did a boo-boo. I should have made this minus. Sorry about that. Note that you can't reduce something inside an absolute value to something outside an absolute value, right? Yeah? Or no? You want to finish? Yeah, okay. So if I do the limit as x approaches 2 from the left, so that's looking at, oops. Should be there. That's going to be this one, right? No, did I make a mess? Yeah, Well, that's just because this is reversed, of course. Yeah, that's better. Sorry. Thought I just had to change some signs. I had to flip the inequality too. Ah! Okay.
Wait, didn't you change the sign like the original one though, like the -5?
Yeah, so those should change down here, of course. Yes. Yes, 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 yes. Okay. Do I have any more typos floating around in this problem before I pick this back up? Aaron. No, because it factors to x minus 3 and x minus 2, and then when we solve, we get positives, right? Is that cool? Okay. Everybody's on board that I got this finally sorted out? My apologies. So if I do that, I'm here. So those can reduce. And when I plug in, I just get -1. When I look at the other side, that's now looking at this piece. So again, we factor and reduce. And again, not equal. Is that okay, Michael?
Yeah.
So again, like basically works the same way. The trickier part was like putting together the piecewise function. I had to think about a little bit like, how do I do that again if I have an absolute value on a polynomial? It's like still just need the zeros. And then just like above is positive, below, above the x-axis positive, below the x-axis is negative. You just use inequalities just like we've done before. It's just kind of a hassle, right? Oh, it looks like you're ready to ask a question.
Yeah. So you got -1 from 2 on the negative side, and then 2 from the positive side is +1.
Mhm.
Is that because the negative side is approaching to the negative? Below?
Well, it's really because this piece is turning out positive. So when I do my direct substitution, I just have 2 minus 3.
Yeah.
And this piece has that extra negative sign floating around there.
Oh.
So it's minus negative of 2 minus 3. So it turned it positive.
Wait, is it, it's like the one with the negative, is that the one that approaches from the bottom?
So it's the one 2 from the right is in between 2 and 3. That's where we said it was negative, right? If I'm going 2 from the right, I'm coming from 3 and going to 2. That's in the negative section where it's below the x-axis, right?
Yeah. Oh, okay.
You see it now?
Yeah.
Okay. I was like, I thought I'm pretty sure I did that right, but I want to absolutely, let's talk it through and make sure. If we're not convinced, you say something, please. I'm eminently capable of making mistakes, so don't assume it's infallible. But I try to do a good job. Okay. And do you guys know how to do the IVT? You feel good about doing that? Yeah. Let's grab one of these guys. I think there's probably a good one in here. oh, here, spin 33 is like that same kind of problem, but now they've algebraed it in a way that it should be doable with no calculator. The same kind of problem as that one we talked about earlier. Or do I not have a good IVT one in here? All right, well, I'll just make one up. It'll be fine. Okay, let's say f of x is x squared minus 1. I'm just going to pick something. Well, let's make it a little bit more interesting. It's x squared minus 1 over x. Let's go. That's better. Yeah, that should be fine. Okay, so let's say this. If f of x is x squared minus 1 over x, show that we have f of c equal to 3 on the interval from 2 to 5. First thing I need to do for an IVT case like this, and the show something exists is classic IVT. Okay, that's my clue. Well, I have to show continuity, right? So what kind of function is f of x? Very good. It's a rational function. So it's continuous over its domain. What's its domain here? All real numbers except for 0. You could write it in words or you could write it as an interval or whatever, but that's enough. So we have continuity. Then what do we need to do? Well, we just need to find a value or an x somewhere on 2 to 5 that's less than 3, or that gives us a y coordinate that's less than 3, and then gives us a y coordinate bigger than 3. What are the two obvious choices to start with? 2 and 5. So if I do f of 2, I get that as 4 minus 1 over 2. That's 3 over 2. That works. That's less than. If I do 5, that's 25 minus 1 over 5. That's 24 over 5. That's 4 point something. That'll work, right? So I can say, since f of 2 is less than 3, which is less than f of 5, there exists a c on the open interval from 2 to 5 such that, well, I should say the IVT states f of c is equal to 3. And we're done. So again, the steps: you show continuity, you find you know, the x that gives you something below the y and the x that gives you something above the y. And then you just state the IVT theorem gives you what you need. That's all you need to do. And the obvious choices for the above and below are the endpoints of the interval. Check that first. It's the simplest possibility. That feel okay? You can do that, right? I'm going to say this one more time. Don't forget to show continuity. Don't forget to show continuity. I will be looking for it. You do need to do it. The AP will, when they're doing the free response questions, guaranteed one point of the question is going to be showing the continuity piece. Even if it's just restating it's continuous because it was like almost given to me in the problem. Yes, Michael.
So when you're showing continuity, like you can't just say it is just like.
This is an extremely specific, like detailed version. If you say it's continuous because over its domain because it's a rational function and just left it, that would be fine.
Like if you said it was continuous, except that like 0.
Right. That would be fine.
Okay.
Yeah. Again, I went over and above on that. And if it was just a polynomial, you can just say it's continuous everywhere because it's a polynomial for sure. Or exponential or what, you know, if it's something that the domain is all real numbers, just it's continuous everywhere because it's, and you're good.
All right.
Totally fine. You don't need to give a domain other than showing that there's no discontinuity on 2,5, right? That's the only reason why I gave the domain there is just to, I can't say it's continuous everywhere because it's not, but it's continuous where it needs to be. And it would the grader would probably give it to you even if you said it's a rational function, so it's continuous over its domain, which covers 2,5. The interval from 2 to 5 would probably still be acceptable that you've stated it's continuous where it mattered. Would probably be fine. Again, I'm not an AP grader, but I would argue for that being acceptable. What do you guys think? Nate?
Could you do one that's
The denominator thing. Okay. So like the limit as x approaches 2 of oh brother, all right. Let's do 1 over x minus 1 over 1 over x minus 1. Oh, sorry, x minus 2. So if I try to do a direct substitution, this is what you're looking for, right, Nate? Okay. First option is always check to see what the direct substitution gives you. If we plug this in, I get 1 minus 1 over something to the, I should probably just say, I should do this. Let's do that. Sorry. So that if I plug that in, I'm going to get 1 minus 1 over 0 over negative 1. So I have 0 over 0, right? So indeterminate, nuts. What I'm going to want to do is try to simplify this and reduce. And I don't know if this is going to be terrible or not because I'm just kind of making this up on the fly. So I apologize if this goes terribly wrong. Is that okay? What I'm going to do is I'm going to look at all the denominators. So x minus 1, 1, and x minus 3. I would multiply the top and bottom of this by the least common multiple of those denominators. So I do that. When I distribute to that piece, I get x minus 3. Everybody's okay there? when I distribute to this piece, I get x minus 1 times x minus 3. And when I distribute to this piece, I get x minus 2 times x minus 1. Is that okay? Now we hold on, cross our fingers, and hope that this works out in a way that I can do the problem. So I have x minus 3 minus x squared plus 4x minus 3. So that's going to be negative x squared plus 5x minus 6, which factors to negative out front, and then it's going to be x minus 2, x minus 3 over x minus 2, x minus 1. Yes. I can't believe that worked out that well for me. And now we can just direct sub in. And I get 1.
So when you're like figuring out the lowest common denominator, you just do as
I look at all the denominators and just take the least common multiple.
and the least common multiple is just like parenthesis denominator parenthesis.
Yeah, I mean in general, yeah. I mean it's like every unique prime factor and then like the minimum degree of each of those prime factors, but like it's never going to be so ugly that like that really matters. You know, like it's not going to be like, oh, bazinga, I have like, you know, like a million things here that I have to FOIL out. Like it's something you have to be able to do by hand potentially. So it's never going to be like monstrously terrible. Like this is, I think, pretty representative of like as bad as it get. Jennifer. Absolutely. Yeah, Michael.
We do 33.
33 from last night's homework?
No, just on the.
Oh, on the multiple choice? Oh, yeah, of course. Is that the last one or thereabouts? Okay. Oh, yeah, this was the one, Finn. It says, let f be a function defined as shown. If f is continuous at x equals 2, then k has to equal what? So this, well, for this, I know that the limit as x approaches 2 of f of x has to equal f of 2, right? So I need to figure out what this is, and whatever that is going to be k. Everybody agree? Since f of 2 is just k. Okay. So the limit as x approaches 2 of f of x is going to be this stuff. Because it's f of x is that everywhere except for 2. So it's just like an open circle, but it's got things going into either side of it. So I know that's what that has to be, right? Well, bloop, bloop. And then I can just direct substitute. So I get 6 over 5. And that's what k needs to be then, to fill the hole. Does that feel okay? So again, like the mechanics of actually doing it, pretty easy, like understanding why you're doing it. That can be a little bit tricky if you're still kind of getting comfortable in the concepts. But the mechanics of what we're doing is usually not too bad right now. Does it get yucky later? it starts getting yuckier. You started to see that in the homework last night, right? Some of those got pretty yucky. Don't worry, they'll get better. Like we'll start showing you the shortcuts so you don't have to do it that way. And then it gets worse because we'll worry about like really complicated examples where you have like layers of shortcuts you have to kind of piece through. But that's usually how things goes. And then you'll get through as hard as it gets mechanically, and then we do application and it gets a little easier. But that's how this course goes. Like you do like the theoretical part, you get to a shortcut, the shortcuts start building on top of each other. You finish with that and you get to application and it gets a little easier. Just kind of like, it's how the course goes. You know what I mean? It's a familiar pattern. If you're doing like truly new math, right? Like it's one thing if it's like algebra 2 where it's the same thing as algebra 1. It's like, well, that wasn't that bad. But you're doing a completely new discipline. Like none of us have ever done any calculus before. So like it's all new, and that's how all new kind of math courses feel. Geometry probably felt that way when you hadn't really done geometry before. Like it started off, it got hard, then it got easy, and then it got hard, and it got easy, you know, like you just got comfortable and things, ideally that's what happens. What do you guys think? You feel okay about like what to expect? Hopefully I've given you like a lot of ideas. Now, typically when I grade these, when I grade your guys' tests, I'm going to grade it as if I was an AP grader. So I'm going to be picky about stuff, but I'm going to, like, we'll make it a situation where I think last year, pretty typically, like, if you had like 85% of the max points, that's going to be a full score. Because I'm going to give you AP style questions. It's going to be time. There's going to be calculator, no calculator. It's going to feel difficult. But like really, I think last year we did 85% was like 100%. So like because on the AP exam, you know what a 5 is? Like percentage? It's like 68 or something, yeah.
So are you saying like getting a 70 would be like 85?
Yeah, I mean, I'll explain to you guys when I grade it what I end up doing, but like, it's gonna feel hard while you're doing it, and that's okay. Like, you don't have to get 100% to get 100% kind of thing, because I am gonna ask you to do hard stuff, and I'm gonna grade it hard, but I wanted to get used to like taking an AP exam where I think a lot of the trouble kids have is they take the first section, they're like, well, I just failed that. It's like, failing is fine. That's like a 4. Like that's plenty recoverable to get a 5 still. You can do this. You just got to keep going. So I want to get you used to a little bit of that feeling. Not quite as bad as like I just failed that. It's fine, but like let me ask you hard stuff.
It's like $2.